Alright, so in this video we will talk about Adair equation, and the main thing about Adair equation is that it's an equation that tells us how an enzyme having more than one site will bind to each substrate. So usually in Adair equation we have an enzyme represented as M. So there's an enzyme M having more than one binding site. Let me just say this one is having two binding sites. How this particular enzyme will react with substrate, that is what Adair equation is all about. So Adair equation could be for a dimeric protein, a tetrameric protein, a trimeric protein, even a pentameric. So but usually for your level they usually give you guys trimeric or tetrameric, or sometimes they want to be easy on you, they will give you dimeric. Okay, so by dimeric I mean the enzyme is having just two active sites, meaning it can bind to just what, two substrates. Abi, is that not so? So if for example the enzyme is having M3, how many substrates can it bind to? 3 substrates. If it's having M4, how many substrates can it bind to? 4 substrates. Is that not so? So the entire Adair equation is just trying to tell you how an enzyme having n numbers of active sites will react with n number of substrates. So if it's having 2 substrates, 3 substrates, 4 substrates. Compare this now with my Kelly-Smelting equation, which tells us how just one, like an enzyme having just one active site react with one substrate. So something like this. If for example I have M reacting with S, just one active site, one substrate, this is a typical Kelly-Smelting equation. But in that equation, M will not be represented as what? As E for enzyme. But in this case now, usually in Adair equation or in this advanced enzymology, your E will be represented as what? As M. So let's go into Adair equation proper now. So I want to solve Adair equation for dimeric protein, for a dimeric protein, meaning an enzyme having two binding sites. Are you there with me? Alright, so I will take the M now. So we have M2. It will bind first to what? To S, and give rise to what? To M2S. Now the constant you will put here will be what? KB1. Are you there with me? Now this M2S again, we can take this M2S to react further because it's not yet saturated. So I can pick my M2S and react with another substrate to form what? M2S2. This now will be what? KB2. Now M2S2 is already what? Saturated. We cannot go further than this. So now let's pick our binding constant. Let's take out our binding constant now. So my binding constant there is what? KB what? KB1 is equals to what? The product over what? Over the reactant. Are you there with me? So we have M2S, which is product, all over reactant is what? M2 in bracket and what? And S in bracket. This one is also reactant, and also. So the idea now is that we are to make this one subject of the formula. So let's make M2S subject of the formula. So I will now have M2S is equals to what? KB1 in bracket M2 in bracket S. So this is my what? Equation 1. Are you there with me? So I choose to put this equation in a different color so that you can understand that this is a major step for you to do. The next thing now is that I will now pick my KB2. I'm done with KB1 now, so I will pick my KB2. So for KB2 is equals to what? Again, product over what? Reactant. This is KB2, right? This is the what? Product. These are the what? These are the reactants. Are you there with me? So let's pick it now. So we have what? M2S2 in bracket, okay, all over. What is the reactant? Look at the reactant here, right? Look at the reactant here. You can see them. This guy, right? And this guy. Is that not so? So let's go down. So we have over what? M2S in bracket over what? Bracket S. Is that not so? Now, what are we going to make subject to the formula? This, right? We're going to make this one subject to the formula. Is that not so? So we have what? M2S2 is equals to what? KB2. You know you will cross multiply now. Let's do it. You cross multiply. Is that not so? That's what I also did in the first one. So we have KB2 in bracket M2S in bracket S. But now we already have what M2S stands for, right? Hope you can see it there. M2S stands for what? Are you seeing this? This is M2S now. Are you seeing what I did? M2S. Look at the meaning of M2S here. Do you get it? So I will put that into this place. So meaning my M2S2 will be equal to what? KB2. What is M2S? Look at M2S here. Is that not so? So pick it. KB1. What is next there? M2. Are you seeing it? M2 in bracket S. Abi. Then I will now write this S, this other S now. This one. I would have write, let me put it here. S. Is that not so? But instead of me to write it there, I will just put S square. Okay, so you'll put S square. S square. This is now my what? My equation 2. Are you there with me? So just to let me just say I want to rewrite this equation again, or there's no need. Let's proceed so you not be confused. It's okay like this. Now once you are done, since it's just 2 equations we have, so we've already make this one as equation 1, like sorry to the formula. We've already made this one sorry to the formula also, meaning we've gotten our 2 equations. The next thing now is to introduce the concept of fractional saturation. So fractional saturation, so the next thing is to introduce the concept of fractional saturation. So we have fractional saturation represented as Y bar is what? Is equals to bound protomer or enzyme, that is the same thing, over bound protomer plus unbound protomer. Are you there? So come to this equation. Okay, this is bound protomer over bound protomer plus unbound, which is over total. Now come to this side. The idea is this side here, this side is the one that are unbound, so we usually call it what? Unbound. Okay, this are the unbound, meaning this one is our what? This is our bound. Are you there with me? Now if you understand that this side, this part here, this part is your bound, is your unbound, then this one is your bound, then let's go down. So meaning my unbound is what? M2 plus M2S. So now come to this, I will now say Y bar is equals to, what is my bound protomer? Okay, let me first write them out. Let me write them out first. So my bound protomer is what? My bound is what? M2 plus what? M2S. Sorry, this is my unbound. So My unbound proton is what? M2 plus what? M2s. How about my bound? My bound is what? Come back to this. My bound will be what? M2s plus what? M2s2. So it will be what? M2s plus M2s2. Now the idea is this. There are certain numbers you will put by the side of this unbound and bound. Now this one is unbound, right? Since it's unbound, it means that it's having two active sites that is inside. So I will put 2 here. This one is just having just one free active site. So I will put 1 here. Do you understand? Why in this side for the bound, I will put 1 because it's just bounded with 1. I will put 2 here. Are you there with me? Let me explain again. I put 2 here because this one is having 2 free sites. I put 1 here because this one is having 1 free site. Why for this bound rule, this rule for the bound, I put 1 here because this one is bounded to just 1 substrate. I put 2 here because this one is bounded to 2 substrates. Okay, so now let's do the total. Total now will be what? If I want to add everything here, it will be what? 2m2 plus what? Plus m2s, abi? Right, 1 m2s plus this one, abi? Plus m2s again, then plus what? Plus this one, abi? Plus 2 m2s2. Meaning the total now will be what? Total now will be what? 2m2 plus 2, when you plot this and this together, will give you 2 now. 2m2s plus 2m2s2. Are you there with me? So this is now my what? My total. So let's go back to that equation now. That fractional saturation, y bar is equals to my bound, right, over total, which is bound plus unbound. Is that also? Alright, what is my bound? What is my bound? Come to this. What is my bound? This is my bound, right? Is that also? So I will just put it there, which is m2s plus m2s2. Is that also? All over. What is my total? This is my total, right? So we put what? 2m2 plus 2m2s plus 2m2s2. Is that not so? Alright. So 2, 2, 2. I will just pick 1, 2. So I have my y bar is equals to m2s plus m2s2 all over 2 in bracket m2 plus m2s plus m2s2. Are you there with me? Alright. So what's the next thing to do now? We already know what m2s stands for. We already know what m2s2 stands for. Okay? So what I'm to do now is just to replace them. Same thing here, m2s and m2s2. My work now is just to replace them. So you remember your equation 1, you replace it here. Your equation 2, you replace it here. Equation 1, put it here. Equation 2, put it here. Very simple, then we're done. So now, my y bar is equals to m2s. What is my m2s? Do you still remember? My m2s was what? kb1, m2, and s. So we just put it there. So here we got kb1 in bracket m2 in bracket what? S, then plus what? m2s2. Where is m2s2? m2s2 that time was what? kb2 kb1 m2 then s what? Square. If you scroll up, you will see it. Then all over here is what? 2 in bracket m2 plus what? What is our m2s? Look at it here again, abi. Then also, so we have kb1 m2 s plus what? What is our M2s? KB2 KB1 M2 S what square. Is that not so? Okay, so for want of space, that is it. Is that not so? All right, now I can still simplify this, but we are done with this equation. I can still simplify it further, but we are done. But let me just simplify. If you want to stop here, you can stop here. So what you just do now is take your y bar. If you notice, there is m here, there is m here in the numerator, so I can just say I will pick out m2, right? Then what am I left with there? I'm left with KB1 in bracket s, then also plus KB2 KB1 in bracket what? S square. Is that also all over this side again? Here is M2 M2 M2, so I can take one of the M2, so I have 2 M2. Here we'll be left with 1, abi? If you cancel that M2, the remaining 1, so 1 plus KB1 in bracket what? S, right? In bracket S, then what is left? Plus KB2 plus KB1 in bracket what? S squared. So this now is our equation. This now is our what? Is our equation. This one's in one separate bracket. You get? So this is our equation for Adair equation for a dimeric protein. If you don't want to simplify more than this, you can cancel this out. Okay, so this is our equation. Writing the equation out now in a more proper and clear way, I have y bar is equals to KB1 in bracket S plus KB2 KB1 in bracket S all over 2 open bracket 1 plus KB1 S plus KB1 KB2 S square. For some people will come and kill me, but it's the same thing. So KB2 then 1. Are you there with me? So with this now, this is your complete Adair equation. In the next video, we will talk about that trimeric protein.